Alright, so the last video in this chapter is going to be looking at binomial estimation. So we can expand a certain bracket raised to a certain power, and then we can estimate certain values by plugging in our x values. It's an estimation or an approximation. It's not going to be a real value, but it's just useful just so we can estimate certain terms. So first things first, if you look at this question here, we need to expand the bracket first up to the first four terms using the binomial expansion we've learned before. So we have 1 plus 2x to the power of 8. And it's just a matter of expanding it. So we have 1 to the power of 8 plus 8 choose 1, 1 to the power of 7 times 2x plus 8 choose 2, 1 to the power of 6 times 2x squared plus 8 choose 3, 1 to the power of 5 times 2x cubed. And they said the first four terms only, so we can just stop here. Now just simplify this. So we get 1 plus 16x plus 112x squared plus 448x cubed. Okay, so that's our initial expansion. Right, in part B, they said by substituting an appropriate value of x, which should be stated, find an approximate value of 1.02 to the power of 8. So we need to find that x value which we need to substitute in. So we're trying to approximate a value for 1.02 to the power of 8. And so what I can do is equate this to what we expanded. So that would be equal to 1.2x to the power of 8. And I can rearrange to find my x. So they're both raised to the power of 8, which I can ignore. So 1.02 is equal to 1 plus 2x. Minusing 1 to each one, we get 0.02 is equal to 2x. Divided by 2, x would be equal to 0.01 or 1 over 100. So this is now what I'm going to substitute into my binomial expansion to get an approximation. So I can say that 1.028 is approximately, it's not going to be the exact value, right? Because when you look at the first four terms, 1 plus 16 times 1 over 100 plus 112 times 1 over 100 squared plus 448 times 1 over 100 cubed. This is our approximation which we should plug into the calculator, and you'll get roughly 1.171648. Okay, so this is the approximation we get when we plug in or find an approximation for 1.02 to the power of 8. So as long as you just state your x very clearly, just equate them together and state them clearly and plug them in clearly, then you can probably get the approximation quite quickly. A common question they could give you is, what is the percentage difference between our approximation and the true value? So a percentage difference would be just the difference between the two values over the original one or over the exact one, right? So the difference would be, the original one would be, if we plug into the calculator 1.02 to the power of 8, that would be the exact value, right? And that's minus our approximation. So this would be the difference between the approximation and the true value. And then we divide it by the true value, 1.202 to the power of 8, and you multiply it by 100, and this will give us our percentage difference between the two approximations and the exact value. So that's the only extra question they could really give you in terms of estimation. But as we said, just as long as you find the correct x value, then you just have to plug it into your binomial expansion.